right, welcome to the overview of the lesson from Friday, um, September 9th and Monday, September 12th. We've been using push pull scales for the past week or so to study contact forces when forces are in contact with each other, whether they are pushing or pulling. We mounted the push pull springs to cars and created collisions with different speeds and masses. And we found that the uh, contact forces are always equal and opposite. So that means that this golf club is hitting this ball with the same force that this ball is hitting the golf club with, which just seems weird, doesn't it? But that's Newton's third law. And I'm going to explain mathematically, or you guys are going to determine and explore mathematically why that's so. But remember, you guys proved this yourselves in data because A and B, the force of A on B, was almost identical when you guys did your lab. Okay, so even though it's very just hard to get your mind around, Newton's third law states that when objects are in contact, they are always equal and opposite. I'll go ahead and add in force. Okay. So we went on to learn how to draw force pair diagrams today because we always want to be able to um, model what we're learning. And so you see I've color coded this a little bit. This is supposedly supposed to represent the blue cars with the push-pull spring on top. As you can see, they look a little bit more like tanks, but that's okay. Push-pull spring. And we know that even if they have a different mass, if we run these two cars into each other, that their forces are going to be equal and opposite. And we know that force is a vector and that it is represented by an arrow. We looked at this arrow a while back, and we noticed that the arrow is pointing in the direction of the force, and that the bigger the arrow, that means the greater the force. So some important things to keep in mind there. So in this case, we know that the forces are going to be equal. We don't know what the force is, but we always want to draw the force with the tail coming off of the object that's exerting the force. So I'm going to draw an arrow, and it's orange because it's representing the this 100-gram car, and this is the force of the 100-gram car on the 50-gram car. It's a little wordy there, but and so I've drawn an arrow to show that. Now, if I'm going to show an arrow that is demonstrating the force of the 50-gram car, I'm just going to color code that. Now, the size of my arrow should be what? Should be the same because the force is the same. We don't know what that force is in this case, but we know it's the same. And I'm always going to label fully these arrows so that someone who is looking at your model would know what they mean. So this would be the force of the 50-gram car on the 100-gram car. Okay, so force is a vector. If you'll remember good old vector from the Minions. Can you remember the name of the movie? And the vector shows direction and magnitude. So the direction is always opposite, and the magnitude we're showing by the fact that the arrows are the same in size. Okay, let's do a different one. Let's do, the good old example of the golf ball that we were just talking about, just because that's something that's easy for me to draw. So I'm going to have the club and the ball, and I'm going to say that the club hits the ball with a force of 50 newtons. So now I'm even more specific. So I'm going to have my club and my ball. And I'm going to say, well, the club hits the ball, as I said, with a force of 50 newtons. So I'm going to make sure and put that 50 newtons on the arrow. But I'm also going to explain that it's the force of the club on the ball. But I know that in all contact forces, they're equal and opposite. So the ball is also exerting a force back on the club, and that it's also 50 newtons. So I make sure to label that. And I explain that that is the force of the ball on the club. Okay, last one. We'll have something falling. We drew several things falling today. We'll do a bowl. That one is easy for me to draw. So if we have the ground and a bowl, so if this bowl, we'll say the bowl hits the ground with 5 newtons of force. Bowl hits ground with 5 newtons of force. So again, we always draw the arrow with the tail coming from the object. So this is going to be a shorter arrow, right? Because it's only 5 newtons. So it's 5 newtons. And this is the force of the bowl on ground. And so why doesn't the bowl just go right through the ground? Well, because the ground is applying a force back up. So it's also going to be a smaller arrow because it is also only 5 newtons. And that is the force of ground on bowl. All right, you'll see some practice that I have posted on Google Classroom, and it is called just that, Force Pairs Practice. So that will hopefully help solidify this idea in your head.